Hi all. Welcome back to our last lesson in Unit 2 of Algebra 2. Today we're focused on linear and absolute value inequalities of two variables. We have already focused on solving linear inequalities and absolute value inequalities of one variable. To solve with two variables, we'll need to use a graph. So let's graph the following linear inequalities. 5x minus y is less than 10. So to accomplish this, I am simply going to solve this for y. So I will subtract 5x from each side. And I'll divide by a negative 1, which will flip the direction of the inequality. So it looks like I have a line that starts down here at negative 10 and goes up 2 over 1. Now, because the inequality is y is greater than and not y is greater than or equal to, we actually have to use a dotted line. But unlike many drawing tools, this one doesn't have that, or at least I don't see it readily available. So I'm just going to go back here, and I hope you don't mind how crude this is, and I'm just going to dot my line like that. All right, so I have a boundary line. Now, I need to represent the entire region where the y value is greater than 5x minus 10. Well, this is the value 5x minus 10. And the y values that are greater than it are all located above it. And I think I have a nice little highlighter here. There we go. So that's where I'm going to shade. Okay? Cool. That's the solution set. The solution set is represented by a region of a two-dimensional graph. All right, let's try another one. Okay, so on this one, I'll use blue. Okay, I'm going to work this problem a slightly different way. I'm going to graph this in standard form. I certainly could solve for y, but I'd like to show you that I have a way that I can do it differently. If I plug a 0 in for y into this boundary equation, I'll get that 3x is equal to 12, meaning that x equals 4. If I plug a 0 in for x, I'll get a y-intercept of negative 6. And these are the intercepts, by the way. They are intercepts because I plugged a 0 in for y to get the x, and I plugged a 0 in for x to get that y. So I'm going to graph negative 6 on the y-axis and positive 4 on the x-axis. And I will go ahead and make this a solid line, or leave it a solid line, since it's got greater than or equal to. Okay, well, the thing about not solving it for y, though, is now I have to decide where to shade, and I don't have something nice and neat like telling me where the y's are greater, and I know y's are always greater up above, and likewise x's are greater to the right. Instead, what I need to do is either solve this for y just to get the direction, or I can do something pretty nice. I can test a point. So let's consider the point 0, 0. If available, that's usually the easiest point to test. So I'm going to test this point 0, 0. So I'll plug in 0 for x and 0 for y. And if I end up with a true statement, then I'll know that this point is a member of my solution set region. Well, that's 0 minus 0, so that's 0 greater than or equal to 12. But that is a false statement. The alligator is definitely not eating the correct bigger amount, right? So what that's telling me is that this side of the line was not where the solution set lied. Instead, it must be over here on this side. So I'll go ahead and shade it. If I wanted to be extra thorough, I could test another point on this side, but I'm guaranteed it would be one or the other. But I guess just for fun, let's try the point, I don't know, how about 7, negative 2? 7, -2 is like over here. And we just colored it in, so it better darn well be right. 3 times 7 minus 2 times a -2. Is that greater than or equal to 12? That's 21, but that's plus 4. That's definitely greater than or equal to 12. So it looks like we shaded the correct side. So two different ways to accomplish the same thing. You can either solve it for y, or you can test regions. I kind of go back and forth. All right, our next one is y less than 5. Pardon the notes, looks like it ran on 2 different pages there, but it's okay. I can make it look like it's on one here. All right, there we go. So y less than 5. Now, y equals 5 would be simply a horizontal line. So this must be a dotted horizontal boundary line. 1, 2, 3, 4, 5. Okay. Now it says y less than, so I tell you what, let's shade where the y's are less. Which is down here. Not too bad, huh? Okay, now it's time for you to do a practice problem. So I think you've got A, B, C, and that's it. So pause the video, give it a try, and then we will meet back here to discuss it. Okay, I've got 7x minus y is less than 7. Let's see what that is. Okay, I think this time I'll go ahead and solve it for y. So I will subtract 7x from each side, and I'll put it like that. And I'll divide by a -1, which means I have to flip the alligator and all those signs. So this is going to be a boundary line at -7. And it's going to have a slope of 7. Wow, that's pretty steep, right? There we go. Okay, pretty steep line. It says y is greater than. That means I need to shade up above. And it's kind of hard. It looks almost like it's to the left, but if you notice, like it is, if I pick one point on the line, I can either go up or I can go down. And this is going up. So that's what we're looking for. Okay, let's try another one. X plus 2y is greater than 0. And this one here, I definitely want to solve for y because standard form equal to 0 is not too easy to graph. So we'll say 2y is greater than a -x. And I'll just divide by 2. Like so. So it's y is greater than -1/2 x. So I will start my boundary line at 0 and go down 1 and to the right 2. And once again, it's a dotted line. So, like so. And now I need to shade, and it says y is greater than, so let's shade up here. This is where the y's are greater. And there we have it. All right, I think we have one more to check here. All right, so x equals a number is a vertical line. So this is a vertical line at -1. And it's a solid one at that. So straight up and down. And then we'll just shade here to the right. Because this is where the x's are greater than -1. Okay. All right, take another second to practice another practice problem. I think it would be good. It just kind of goes over the concept of what it means to be a solution. So pause the video and try practice 11.2. There it is, just in case you don't have it in front of you. Okay, now it's time for us to give it a try. Given this inequality, 5x minus 2y greater than 10, determine whether or not the following coordinates are solutions to the inequality. So we could draw a graph, but the graph is inexact. What we really want to do is plug in the points and see if it makes a true statement called a tautology. So I will plug in 3, 0. So 5 times 3 minus 2 times 0, is that greater than 10? That's 15 minus 0, which is definitely greater than 10. So this must be a solution. Yes, it is a solution. What about 4 comma 5? That's 5 times 4 minus 2 times 5. Is that greater than 10? That's 20 minus 10. That's not greater than 10. It's equal to 10, but it's not greater than 10. So, no. What about 3, negative 1? 5 times 3 minus 2 times the negative 1. Is that greater than 10? Well, that's 15 plus 2, which is 17. That's definitely greater than 10. So, yes, that's a solution. All right, time for me to teach something a little bit different here. We've seen how to graph absolute value equations. Now we're going to graph absolute value inequalities of two variables. So we're simply going to graph and shade a region. This is an absolute value graph that has been shifted 2 to the right. So that's 2 to the right. It's shifted 3 up, and it's flipped downwards. So usually they make a V just like that, going up 1 over 1. This is going to instead move 2 to the right. The little point of the V is what we're moving. 2 to the right and 3 up. And then we'll, instead of going up 1 over 1 because of the negative in front, we'll go down 1 over 1. Oh, and that should be dotted. Oh, I can come back and dot it. There we go. Grabbing the old eraser. Dot, 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 dot. Okay, and now we need to shade where the y's are less than. So find a point on the line and go straight down. That tells you where the y's are less. Down here is the region that we are shading. All right, let's do another example. So hopefully you see this is basically the same thing that we were doing earlier in the lesson. It's just a different shape. All right, let's do this one. All right, this absolute value graph, the V, the little point of the V is simply moved down 5. Nothing else has changed, so we'll just move down 1, 2, 3, 4, 5 to here. So it's going to go up 1 over and up and over and up and over until it gets to 5 here and here. And it is a solid line because of the bar underneath. Remember, this is what tells me to make it solid line, that it's greater than or equal to. And I want to shade where the y's are greater. So that's up here. Okay? And I'm being a pretty sloppy shader right now, but you get the idea. It's all of this stuff. Okay, I think it's your time to practice that. So give it that a try. We have practice A and B, and then your exit ticket. Okay, hopefully you have had some success here. Let's do it. All right, I'll use orange this time. Okay, this time the absolute value, the little point of the V is moved 1 to the left, and then it is flipped over, and it is going to be stretched by a factor of 2. So we're used to going up 1 over 1, up 1 over 1, but instead it's going to go down 2 over 1 like this, and it'll do that in both directions to make the V. I need to go back and make it dotted, though, because it does not have a bar underneath, right? It just says greater. It doesn't say greater or equal. Now we need to find where the y value is greater than this curve. Well, that's where they're above this curve. Make sense? This thing doesn't even erase very well. All right, there we go. It's good enough. So where is it greater? It's greater all the way out here. So we're just kind of carving it out this little triangle shape in the coordinate plane where it won't be shaded. All right, one more. Here we go. Going to move to the V to the left 5 and down 1. And then it's a solid line. There's no stretch or flip, so it's just up 1 over 1. So something like that. And we're shading where it's above. All right, well, hopefully you had success with that, and I will see you in the next unit.